Okay, guys, so welcome back. Now we start solving question 2 from the homework number 4. And this question had 2 parts. So 2A was about the manual computation of the fast Fourier transform. So let me just write on the questions as it is. So basically, this is the C that is given. It is 2, 3, 4, 1. And we would like to find y equals FC using the FFT. Okay, one step of the FFT, in fact. So basically here, you know the steps here. So basically we had to extract the 2 vectors, C prime and C double prime. So C prime is, how much is it? It's going to be composed of C0 and C2, the even components. So it's 2, 4. And C double prime is composed of the odd index components of 3, 1. Okay. So C3 and the C1 and C3, so it's going to be 3, 1. Okay. 3 and 1. Now, to obtain y prime, so basically y prime is what? It's F2. So the Fourier matrix of size 2 multiplied by C prime and divided by half. So it's going to be equal to half of F2, which is 1, 1 minus 1, multiplying 2, 4. So if you do the math, you end up with half of 6 minus 2, which is 3, negative 1. This is for y prime, and of course y double prime follows the same pattern, but you multiply by C double prime, so you get half of 1, 1, 1 minus 1 by 3, 1, which means you get half of 4, 2. So now you get 2, 1. Okay, now the next step, so this is step 1 of the FFT. Now step 2 is to do what? To define this D, which is going to be distributed, where what is equal to 1W, okay? It should have the same size as y prime and y double prime because it's going to multiply them. And what is W here? We said W is e to the power 2 pi I over n. Which n we are using? We are using n equals 4. So it's going to be e to the power pi over 2 I. Pi over 2 I. Okay? So now, which means that the W itself, what is it? It's just I. Okay? So basically D is 1n I. Okay? I'm going to write this part here. Continue. So to compose y, you basically write y prime plus the distributed product of D by y prime. And the next part is going to be y double prime, sorry. And it's y prime minus the distributed product of D by y double prime. So this is what you're going to have. You're going to have 3 plus 2. Second component is going to be minus 1 plus W, so minus 1 plus I. It's going to be the third component 1, and here it's going to be minus 1 minus I. Okay, so basically this is y. 5 minus 1 plus I, 1 minus 1 minus I. So this is for the first part. Now the second part, we asked you to do what? We asked you to verify that, in fact, f, which is equal to 1/4 of capital F by C, of course here we're talking about the Fourier matrix of size 4 by C, is equal to half of y. So all we have to do is just to compute, first of all, what is capital F and multiply by C and check the result. Well, here we're going to have F, which is equal to 1/4. What is F? It's going to be 1, 1, 1, 1, 1, 1, 1. And here the components inside are I minus 1 and minus I. Third column, you're going to have minus 1, you're going to have 1 and minus 1. And the fourth column, you're going to have minus I, minus 1, and finally I here. Okay. So this is F4 multiplying 2, 3, 4, 1. 2, 3, 4, 1. Okay. So if you do the math, you get the following. F, which is equal to 1/4 times the following 10 minus 2 plus 2i, and you have 2, and you have minus 2 minus 2i. Okay. So check with me. This is equal to what? This is equal to 5/2 minus half plus half I. You have half, and you have minus half I, the last component. And of course, as you can see, this is nothing but, if you consider that one is the row and the other one is the column, of course, this is equal also to half of y. Okay? So that's it. So that's it for this first part of this question. I'm talking about question 2 from the homework. And thank you for following.